This is a little bit of an experimental video. I've upped the frame rate to see if I can get things a little bit clearer on video, so I won't know until this comes out, see what it looks like and see if it's a waste of time. But if it's good, write to me in the comments and I'll keep doing them like this, if it works. So what's today's video? Well, I was wanting to respond to a comment below on a previous video, and the comment was about, somebody asked me about his wheels on his Range Rover were jumping around corners. And I said I know exactly what it was, because it was a Range Rover Classic and the viscous coupling seized up. What's a viscous coupling? That's a viscous coupling. Very simple little device. And it's very clever how it's made. It's got a shaft, a spline on the inside here. It's also got a spline on here and a spline here that goes through your drive shaft flange. Well, do you want to know how it works? It's very simple, and it's so simple it's stupid. Again. It's a self-contained unit, you can't really get into it. Ashcroft's rebuild them apparently. Well, we've got none in stock. But anyway, how it works, it's rather reminiscent of a motorcycle clutch. I'll put a picture here and you can see there's inside here, there's a series of flat metal plates with holes in. And you'll see that there's some splines on the outer ring and there's some splines on the inner ring. So they're all sandwiched together, so it's got splines on the outside, splines on the inside, splines on the outside, splines on the inside. Like I say, it's rather reminiscent of a motorcycle clutch, but without the friction material. But how does it work if it's self-contained and there's nothing to push the plates together to make it drive? It's very clever. It's filled with silicone, or a silicone derivative. And what that means is, when you've got the two plates together and you've got silicone between them, when there's an excessive force turned on, like a torque, the silicone makes a pressure wave and it expands ever so slightly. But with a multitude of plates, that causes the whole unit to lock up. It's rather like a viscous fan. It's the same idea, except on the viscous fan at the front, you've got a bimetallic strip that turns a lock that pushes the plates together so they clinch together even tighter, if you see what I mean, so the fan turns. Easy. So what are we going on about? Well, these here are like chicken's teeth to find now. When these were new, they were 1,000, well, they're 1,300 pounds new from Land Rover, but they ain't got no stock. Ashcroft's got no stock, they're 350. I had a quick look at Craddock's. They're 450 plus 100 and, I think it was $180 180 pounds exchange. Well, I happen to have not one, not two, but three of these units in my possession. But I need to test them. How am I going to test them? Well, it's kind of easy really. You need a spline to go inside here and something to drive off this spline here. And the idea is, this inner spline is going to be fixed, and you're going to apply a torque to here, get this, of 20 foot-pounds for 1 minute, and it should turn between 20 and 30 degrees. Well, I haven't got anything like that. What I need is a Borg-Warner gearbox. My God, there's one here. Look at that. How convenient was that? Right, I've got to edit this bit because I forgot to tell you what happens with these viscous couplings when they fail. They can fail open, that means they'll just spin round and you'll get no drive, or they will fail locked up, and that means it's like having diff lock, your centre diff lock, applied all the time. So the idea is there should be some movement on this flange. If it's locked up, it's buggered. If it goes straight round, it's buggered. But there should be some resistance. Now in the book it says turn this at 20 pounds, I can't remember what it was in Newton meters, for 1 minute, and you should, you know, it should move. 20 to 30 degrees. Now, I've got some marks on this pulley here, but when I put 20 pounds on, which isn't much at all, you can sort, well, bloody gearbox is moving there, look. It's very hard to get 20 pounds, but you can actually see it moving, look. You can see it moving. Now, is it going to take a minute? Well, let's try it. Yeah, that's 12. Right, and that's a minute, look. So it's moved from here to here in a minute. To me, that seems a good torque converter. And what am I talking about? That to me, that to me seems like a good viscous coupling. It really does. And I know this gearbox has only done about 75,000 miles, so it ain't done all that much. So how do we change it? Because what we're going to do now is going to put this one in, because this was on the shelf, so I don't know what it looks like. So let me get my oil canister out so we can catch any falling oil. We're going to take off the ring of bolts around the outside of here, catch any oil, pull this off, take the nut off here, obviously, take the flange off, and swap this piece over and see if this one here works the same. To change the coupling couldn't be easier. You take the flange off, well, we've already got the nut off this one, so we'll pull that off. You've got to take this bar off the side just to gain access to the bolts, and it's also fastened to this housing. You take that off, and also you take off the motor mount, the gearbox mounting, which is already sheared off, so that's a waste of time, isn't it? And then you can get to the bolts. So I've got my oil drain underneath. Let's see if we can get the bolts out. Is all the bolts out? Looks like it. Right, I've got the bowl underneath to catch any oil. Does this come out? I've never taken one of these out for years. There's a circuit behind there. Wouldn't have thought so. Let me go and get another pry bar. Well, according to the book of words, all we have to do is pry it off. There's no clips in it. Here's my post lady. That should just come off. That should slide out of there. Oh, I see, we were on the bearing. That's it, so now we need to get that bit off. I wonder if this is on the bearing as well. Hey! Well. Well. Now it looks like I've only got two. Good thing I took it off. You can probably see in here the splines are knackered. Let me get some brake cleaner and clean it up. So perhaps now you can see why I had a difficulty getting it off. You can see there's a difference in the tooth pattern here. You can see right at the very back, you can see where it's worn because there's the original tooth. And because it's belled over here, you know, it's worn on the end, that's why I had trouble getting it off. And this is one that looks like that should be good. I'm just wondering, when I'm looking at that, that this spline was probably shot as well. But I'm just wondering, this looks the signs of a seized up coupling, but it shouldn't be. Or there's been something wrong with it, or there's been a lot more miles on it than we see on the speedo. So what we'll do now is we'll put this one in and we'll just test it. What a difference a good spline makes. See, that's how it should go. Let's put the flange on. Right, let's check this one, see if it's seized up or it's turning. Now, I should have mentioned, I've actually locked up the rear handbrake. You know, the transmission brake? That's locked up so that none of it turns. And that is working lovely. That is working really, really nice. Look at that. I'm not even going to look at the measurements. You can see me slowly putting a little bit of pounds on it. That one's a really good one. I'm not going to bother with that one. That's really good. What a shame with a knackered one. Watch me get them mixed up. But that's what we're looking for. Teeth wear in them as well. Because you see, if you sent this one back to Ashcroft's or Craddock's, anybody like that who do an exchange service, they'll look at that, throw it in the bin and keep your deposit. Just be careful. So that's that. So what do I do now? Do I build this back up? It's very difficult actually without stripping this whole assembly down to see what these splines are like, because they look quite good on the gear here. They look really, really good. But the problem is, do I want to put any money into it to build this up all nice, shiny, clean, just like the LT230s, and not sell it? It's a problem, isn't it? It really is a problem. Because I don't want to, I'm in the point of getting rid of stuff, not gathering stuff up. And I don't know how much the kit from Ashcroft's is to repair these. Let me find out. So here we go. Some prices from Ashcroft's. The chain, sold separately, is £320 British pounds, or 500 Canadian dollars for a chain. The bearing kit is £116 or 180 Canadian dollars. And the viscous coupling, which they don't have in stock, is £320 or $500. Now that seems a bit expensive to me, but if you want a complete box off Ashcroft's, one of these boxes here, £745, which is 1,200 Canadian dollars, plus exchange, plus shipping, and shipping it back. If not, there's a car charge on it, which will push it up even further if you don't send the old one back. Not cheap, eh? You know, I like to keep old cars on the road, but I don't know. When people have this problem, it gets kind of, you know, like head scratching as to what to do.